Hello guys, welcome back. So we were explaining about the displacement current. So as we know that del cross H is equal to 0, that H we can take any vector at this place. So this property is we would learn in the when we do the chapter 1. Curl or divergence, I think you should do it because it's very important and it's not that much tough, so it can be handled. So now del cross H is equal to 0 according to the property. So if del cross H according to circular law is equal to J, so del dot J equal to 0, but del dot J equal to minus d rho s by dt according to which equation? According to equation of continuity. Alright, so that means there will be some current that is equal to del, that is d by dt of rho s. And what is rho? Rho is as shown here, rho is del dot d. So if we put it in the equation, we will be getting, after solving this, equal to dd by dt. So this is not a concern right now. So this equation says that current produces magnetic field, and this equation shows that magnetic field produces electric field. Alright, so what is the main thing is that from, see here, it is electric field, basically D is what, epsilon E. So electric field is being derived, is once derived and differentiated, that is d by dt, and then we get the magnetic field, and then magnetic field is again differentiated, then we get again electric field. So this cycle goes on, and this cycle goes on and form what, the wave equation, that is equal to del square E by dz square equal to 1 by c square del square E by dt square. So how is, why there is double derivative? Because of this only. D produces H produces E again. That's why there will be double derivative in the equation. Alright, now coming to the other things. Now as we saw in the third and fourth equation, if we put like in this equation it was dB by dt, so we can write d equal to mu h. So from that we get mu dh by dt, and then if we can write the density, current density, as sigma E, and again we can write d is as epsilon E. So what will we getting? We will getting mu, sigma, and E. What are these things? These things are the material's constants. Why? Because these things depend on the material. The whatever material we will be having, they will be having their unique value, and according to that the electric field and magnetic field change. So magnetic field and electric field change according to the material we have. Alright, so using this we can find some parameters for the magnetic field, and these parameters are gamma. First of all gamma, then gamma is called the propagation constant, and then eta is called the impedance, basically impedance, whatever what we say is impedance, like we did in our networks. Its own unit is ohm only, but here it is found like E by H only, E through E by H value. So first coming to the our propagation constant, it is basically a exponential decaying function. So it will be having everything which is decaying the signal, that is the signal, that is the electromagnetic field in the medium. So this will also be decreasing it, and this will also be decreasing it. How it is decreasing it? See, this is called, this alpha, this is called attenuation constant. So if a signal, it is basically attenuating the signal by as the distance increases. So as the distance z increases, there will be some the attenuation in the height or amplitude of the signal as we move through the z axis. What is the beta doing? It is attenuating, or you can say changing the phase. of the same wave. Alright, so these two things are very important constants. Now, but the most basic formula that we can apply to every medium is j omega mu plus sigma plus j omega e. So what is this? J omega mu is into sigma plus j omega e. It is gonna give, using all three material constants to get us the value of exponential decaying function, that is our propagation constant. So we will be getting it, and these three mu, sigma and epsilon depends on the medium. So if we, when we are covering it from medium to medium, it will be changing accordingly. Like for lossless medium, sigma is equal to 0, then we will be left with only j omega mu and sig and epsilon. So j omega can be taken out, and like that. So every medium can be defined by this only two three formulas, and the only first is this, second is this, and sorry, again we forgot to discuss about the eta. E by h is one of the way to find it, and the other way is j omega mu by sigma plus j omega e. Excellent. So this is, you just need to remember that j omega mu is always in front, and then it will be divided in the denominator in the form in eta, and in sigma in lambda it will be multiplied. Alright, and the third and most important thing is Vp. So what is Vp? Vp is the phase velocity. So how there is a different phase is what the difference in the uh, corresponding consecutive waves is called phase velocity. So basically it is velocity of the wave only. So if we find it can be found by lambda f as we find the speed of light. It can be also like that, and or and it is can but the most used formula here is omega by b. So when we find b here, we will put it in denominator and put omega in the numerator, and we will find the value of p. So now the most important thing about this chapter is polarization. Most of the questions are asked from this topic, and this topic can be explained in this only 2 3 lines. See, whatever may be the equation, just see two things: phase and amplitude. If the phase differ, first, most of the time it will be circular. Sorry, I have written equatorial. It's like elliptical. So the first thing is seeing the phase, and if there will be phase there will be x component and y component in every equation. If there is not, then you can directly say it's like linear polarization. Or now if there are x and y component, then it can be linear or elliptical or circular all. So then the case arises that we need to see the phase, that is phase which should be equal to dif- uh, phase should differ by 90 degree, then it will be a circular or elliptical. Alright, and if the amplitude is equal, so see, for circular you need to see these two conditions. If these two conditions are equal, phase differ by 90 and amplitude are equal, you don't need to look at any other option, it will be circular. But it will be elliptical if the amplitudes are different. This is the simple difference between elliptical and circular. So now how to decide it is, and now how the how can we find the linearity, if it is linear or not? Just see the phase. If the phase in cos theta or sin theta, yeah, x component y component is like same, you don't need to see any other thing, just simply say it's linear, because in elliptical or circular the phase difference should be 90, uh, and in elliptical also it can be other than 90. Then it will not be along x-axis or y-axis, but it will be elliptical. So now the other important thing is how can we find it is right-handed or left-handed. So this is the point that we all get get stuck on, and we just the best trick is to see the component. Ay component is greater than ax, just remember it's left-handed, nothing else to remember, and vice versa. If ax is greater than ay, it will be right-handed. All right, nothing needs to worry about anything else, it will be directly found. All right, now the pointing vector, the other important point in this chapter is pointing vector. That is, pointing vector is what, just it's the power density only, but that is we divide the power by meter square, we find the, and that there will be two types of question there, that we will be find, we will be wanted to calculate the power, and power can be calculated if we get the density, then if we multiply by area we will get the power. And then pointing vector or power density, then we can be given the equation, we need to find the magnitude of electric field or magnetic field, whatever in the equation is given, and apply this formula. Here eta is equal to 120 pi, you can take it every time. All right, so and what will be the last equation, it will be when, see, magnitude calculation is a difficult task when you just need to take everything into consideration, even the unit vectors, to calculate the magnitude. So we will discuss about these cases in the lecture. We will be solving the questions on this, and then it will be like crystal clear. So now coming to the important law, that is a very easy law. See, it's basically all Eichmann constant. So Snell's law, n1 sin theta 1 equal to n2 sin theta 2, and is reflective coefficient here. It is not eta, so don't confuse it with eta. So, and we can directly form the equation. And Brewster angle is also sin theta, is the angle at which whole of the wave is the, you can take it as when whole of the wave component passes on to that is reflected or transmitted, then it is called Brewster angle, the angle at which whole of the wave is transmitted. So now which type of waves gets transmitted? So here we come, there will be two types of waves. If the waves in which electric field is parallel to the surface, then it is called S-plane wave, and if it is perpendicular to the surface, then it is called P-plane waves. So Brewster angle works only with P-plane waves, okay, but critical angle works with both. So whole P component passes on, while at the critical angle it works for both P and S, as I have written. Now come to the other important thing, and one of the most important, and many questions have been asked on this, that is boundary condition. And you just need to follow this step, and you will find that you will solve every gate questions that have been earlier asked. See, first it will be given like ax, ay, az component in the equation, and we needed to find the other component, that is the electric field on the other side. So it can be directly calculated by using E. First we need to find the normal component, so we need to find what is the component. So suppose it is z component. All right, z is the normal, so we multiply, we take dot product of az into the whatever equation we are given, a 2ax plus 5ay plus 3az, whatever we will need to multiply, and we will be getting only the, we will multiply only the z component, because dot product az into az dot az is equal to 1, other components are 0, so it will give us the normal component. And if first we and now we are done with normal component, then we can find the tangential component uh, by subtracting the normal component from the equation, and we will get the tangential component. And as we know that tangential components are equal at the surface, so we can get the et1 equal to et2, and we can find et2. Now why are you finding et2? Because the whole equation after that, the electric field after the in the second medium equal to e2 et2 or plus e2n. All right, so normal component plus tangential, so we found the tangential component using the first equation, that is et1 equal to et2. Now the second condition at the surface is dn1 equal to dn2, so we can find it directly by epsilon 1 e1n equal to epsilon 2 u2t e2n. So e2n will be found because epsilon 1 and epsilon 2 value will be given. Sorry, here I forgot to put the under root here, so just put the under root upon the epsilon 1 and epsilon 2, and it will be easy to find the e2n after that. And uh, when we get e2n plus e2t, um, then we can directly find the e in the second medium. So applying this, you can find almost all the questions of normal incidence, and I hope this will be enough for solving the previous year's gate questions. But I have not done here is oblique incidence, so it will be done in the chat in the later videos. But most of the questions are asked from the topics I have covered in this video. So after this video, I'll be applying all the concepts I have told here will be directly applied to the questions of gate, and I'm sure it will be very beneficial because you can solve every question. Alright, thank you guys for watching. See you in the next video. Alright.